level. Have you understood this? The same is explained in theory in your book. Without giving any examples, they have stated this. And B to A, right shift, and check this bit and all they have stated. Without working out an example, will not be able to do that. After working out an example, now you will be familiarized with and you'll be able to write what it is. Okay, for that purpose, I took this. Now we'll see the hardware implementation of this. We saw binary arithmetic and subtraction, and we saw the hardware implementation. Similarly, we see how this can be done. See, you have three registers as we saw. You have a A register and E register being initialized to 0. Right? We saw just now we saw the algorithm. Now A and E has been initialized to 0. Q register, you're taking the rightmost bit, that is the least significant bit, and you're checking whether it is 1 or 0. For checking, rightmost bit alone is there to check. And then what we are doing here is, this is a sequence counter which gives a sequence of instructions that you are going on. This is the B register which is giving you the number. So this is one, in case of necessity you have to add. Complementer means in case you want to shift it, you will be shifting it. So this is the block diagram or the hardware implementation of ordinary multiplication. What we saw just now, to implement that multiplication, we have the hardware set up like this, and we have this flowchart here. We have 7 minutes more. I'll just tell you this Booth algorithm. We are going to have the arithmetic right shift. In case of arithmetic right shift, what we'll do is the first bit will be written as such, and then it will be shifted subsequently like this. That's what's called arithmetic right shift. In Booth algorithm, what the advantage is, in this ordinary multiplication algorithm, we are dealing with the number separately and then the sign bit separately. In Booth algorithm, whatever the number may be, the negative numbers are also dealt with along with their sign. So the negative numbers are given only in 2's complement. You know what do you mean by a 2's complement? The binary number has to be converted zeros to ones and ones to 0. That's 1's complement. And adding 1 to that will be the 2's complement. So in Booth algorithm, what we are going, the steps that are followed is we are calling here accumulator as A. In Booth algorithm, we call that as AC. And here we are taking two registers as B and Q. In Booth algorithm, we'll call that as BR and QR. As we saw here, the sequence counter, the same, it will be initialized with the number of bits. And as you keep on doing the process, it will get decreased. So you should see to that the number of bits is equal to the number of steps that you are doing in Booth algorithm. Number of steps that you are following to find out. And always in Booth algorithm, when you are going to find out the product of two numbers, the negative number should be represented only as a 2's complement number. So here you will be checking what is the bit in QR, the least significant bit in QR and AC. Based on that, you have to take up the decision whether the addition has to be done and arithmetic right shift has to be done. I will take the animals more. We'll see the flow chart for Booth algorithm.